Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 4 Vectors and Three-Dimensional Geometry. Topic Vectors. Subtopic Vectors and Scalars. Magnitude and direction of a vector. Direction cosines or direction ratios of vectors. Types of vectors: equal, unit, zero, parallel, and collinear vectors. Position vector of a point, negative of a vector. Exercise 10.1. Scalar quantity. A physical quantity which has magnitude only is called a scalar quantity. Magnitude खक्तंग लैबा physical quantity amabu scalar quantity नत्रग scalar हाइना कवे. Example: length, mass, time, distance, speed, area, volume, temperature, work, money, voltage, etc. हारिबा physical quantity सिंग असि measurable quantity ngaktane. मखोइसिंग असि magnitude खक्तना मपुंग फाना मसक ताकपा याय. Length हाइरगदि 5 meter, mass 5 kg, time 5 hours, distance 5 meter, speed 5 meter per second, area 5 square meter, volume 5 cubic meter, temperature 5 degree centigrade, work 5 joules, money rupees 5, voltage 5 volt, etc. हारिबा सिंग असि अखोइना नंबर अमगा यूनिट अमगना फोंदोई. Generally scalar quantity सिंग असि नंबर अमगा यूनिट अमगना फोंदोई. Vector quantity of vector. A physical quantity which has both magnitude and direction is called a vector or a vector quantity. Magnitude amasung direction animakna mapung phana masak takpa ngamba physical quantity amabu vector natraga vector quantity haina kawe. Example: displacement, velocity, acceleration, force, weight, momentum, etc. Makoi sing asi vector quantity ni maramdi displacement point ani gi marakta leiba displacement haibasi shortest distance tuni maikai yauba pot amani. Velocity 5 meter per second with knot hairagadi speed plus direction ni. Acceleration 5 meter per second square hairagadi mahag asi maikai amasung magnitude yawe. Force 5 meter per 5 newtons in knot hairagadi magnitude amasung maikai yawe. Weight 5 kg or 5 kg hairagadi 5 kg weight hairagadi weight is acting downwards ni magi maikai momentum gisu mv mahag gisu velocity vector quantity possess towi. Haribasing asi magnitude amasung maikai magnitude amasung maikai ani nam punna masak takpa ngamme maram asina masibu vector quantity sing kawi. A vector is represented by a directed line segment AB. Vector ama haibasi maikai takpa lai amana haibadi AB iraga marakta mathakta arrow head ama yauraga mahut sili. Vector ama haibasi maikai takpa lai makak amana mahut sili. Or simply small letter with arrow head arrow mathakta arrow hapagasu vector amabu mahut sili. Ayekpa picture asida A amasu B haiba si vector A B bu mahut sili masi A na su khangnai madu arrow ama yauri basini. Where A is called its initial point and B is its terminal point and the direction is from A to B. Mafam asida A asibuna our initial point, B asibuna terminal point, direction asidi A dagi B dani. The distance between the initial point A and the terminal point B is called its magnitude or length and is denoted by AB vector dot with single bar taken bar bounded by single bar taken bar or A vector oragana A vector the single bar taken bar na bounded oigani or simply A katang arrow lothokrasu A katang iraga bounded symbol yaudраbasu magnitude pu khangnagani. Aduna distance between the initial point and terminal point B is called magnitude or length haibani. Magnitude of a vector is what is a non-negative real number. Maramni point ani gi distance habasidi piklabada 0 chawro aduga can take any real number. Magnitude of a vector is a non-negative real number which is the length of the line segment representing the vector measured in a suitable scale. Direction angles haiba matang charing sida chapter tam ama ani khaktang naina hausi. If alpha, beta, gamma are the angles made by a vector r with the positive directions of x, y, z axis respectively. R haiba vector amana positive axis singa semiba and direction positive directions of x, y, z axis singa sem angle singdo mathang sitna alpha, beta, gamma lowrabadi is in picture. OP represents the vector R. Mahakna OX positive direction to X axis ka semi angle se alpha. Aduna OP or OP vector or R vector sina OY positive direction to Y axis ka semi angle se beta. Asumna OP vector natraga R vector sina positive direction of Z axis ka semi angle se gamma oire. Then alpha, beta, gamma are called direction angles of the vector R. Alpha, beta, gamma C vector R sigi direction angles sin kawe direction cosines. If alpha, beta, gamma are the direction angles of a vector R, then cos alpha, cos beta, cos gamma are called direction cosines of the vector R and denoted by L, M, N respectively. Direction vector amagi direction angles sing aduda cos toksilaga phangba number ahum dubu direction angles of the vector kawe makoi sing asi matung tabadadi L, M, N haiba small letter ahum sina mathang sina mahut singani. Consider the position vector or P vector or R vector of a point P whose coordinates are x, y, z. P haiba point asegi position vector with OS origin oiragadi ana mahut silase. We have cos alpha is in picture. Cos alpha have a sig angle OLP have a right triangle amani right angle at OLP angle as right angle ni. Then the OP is hypotenuse ore adurabade mahakidi OP abasina OLP mahaki cos alpha di OL kya sang basi x ni x ta mahaki radius r na yelabadi OP ga asang basi r na yellow based by hypotenuse di cos alpha ni cos alpha di x by r asumno cos beta su y by r cos gamma su z by r r haribasi mafam asida modulus of r vector buni cos alpha bu L na mahu sindokrabadi x equal to LR cos beta bu M na mahu sindokrabadi y equal to MR cos gamma bu N na mahu sindokrabadi z equal to NR. Here R is modulus of vector R. The coordinates of the point P are hazik point P ki coordinates sing say direction cosine sing da express to yare L R M R N R haina. Direction ratios. Any three real numbers which are proportional to the direction cosines of a vector R are called direction ratios of the vector R and denoted by small a, small b, small c respectively. Karigumba vector R haiba amagi direction cosine singa proportional oibar any real number ahum amabu vector dugi direction ratio sing kawe makoi singa si mahosana small letter a b sina mahut sille. Now types of vectors. Vectors singi makhan sing zero vector or non-vector. A vector whose initial and terminal points coincide is called a zero vector or non-vector and denoted by zero with arrowhead. Zero vector can take any direction. Meg ahoba amaso aroiba bindu sing lonsinaba vector amabu zero vector natraga non-vector kawi. Zero vector sing asidi zero da ma zero gi matakta arrow ama hapaga khangnei. Zero vector can take any direction. Zero vector gidi maikai si lawning maikai lawba yai arbitrary. The vector AA with arrow ahead represents the zero vector. Aho AA machine su zero vector bu mahut sile. Unit vector. A vector whose magnitude is unity is called a unit vector. Magnitude 1 oiba vector amabu unit vector kawe. The unit vector in the direction of a given vector A is denoted by a cap, read as a cap. A vector sigi maikaida satpa unit vector amabu a cap na khangnagani pabada a cap haina pagani. Co-initial vectors horokpha manaba vector sing. Two or more vectors having the same initial point are called co-initial vectors. Ani natraga ani degi henba vector sing horokpham chap amatta oiba vector singbu co-initial vectors kawi. Ayekpa picture asida a vector, b vector, c vector, d vector pumnamak odagi start kawi. Mathangda collinear vectors. Two or more vectors are said to be collinear if they are parallel to the same line irrespective of their magnitudes and directions. Ani natraga anidagi henba vector simu collinear vector kaugani makoi singado sub manaba line da parallel oiba makoi gi magnitude amasung direction dudi athingba leitragasu. Yegliba picture sida a vector, b vector, c vector singase collinear vector singni maramdi makoi singase maikai opposite oro maikai same oiro but makoi gi line of action makoi gi kanu singase line singase loina same line da parallel oi. Equal vectors. Two vectors, a vector and b vector, are said to be equal if they have the same magnitude and direction and written as a vector equal to b vector as in picture. Vector a vector ga b vector ga magnitude mane maikai mane and is equal vector ni. But c d hariba lemhoriba vector and is ama makoi amata equal oide a ga c ga su oide a ga d ga su oide asumna B ga C ga su oide B ga D ga su oide equal habadi maigai su managadabani magnitude su managadabani. Negative of a vector. A vector whose magnitude is the same as that of a given vector but direction is opposite to that of it is called negative of the given vector. The negative of the vector AB is denoted by minus prefixing to the vector AB vector or simply be a vector. Ayekpa picture sida AB haribasi apiba vector amani mahaki negative ti B A ni ma ani vector ani si magnitude manai maikai opposite oi. Apiba vector amagi negative haribasi magnitude manaba mahaka magnitude manaba maikai just opposite oiba vector amabu apiba vector dugi negative kawe. AB vector gi negative si minus mamang da tapaga minus or AB busu khangnai or BA initial point ga terminal point ga interchange taunaraga iba vector adunasu negative of AB vector bu khangnagani. Position vector of a point. Let O be a point in space and P be a given point. O habisi space taliba point namani P habisi swapiba point namani. Then the vector OP is called the position vector. P full stop B full stop matung taba chapter singda position vector habisi short yam toini seasonarako word ama oigani aduna koine short form introduce story of the point P with O as origin. O habisini space talaiba karigumba point amani P habisina apiba point amani O dagi P da chatliba directed line shape and sina position vector of the point P with respect to O as origin haina kaugani. Exercise 10.1. Represent graphically a displacement of 40 km 30 degree east of north haiba. Asigumba 40 kilometers awangdagi nongpoklomda 30 kilometers satpa haiba be displacement asi 40 kilometers se graph ki mateni yu haibani. The vector OP hai odagi na P box 40 kilometers sangba bu treat tawre aduga mahana north dagi east from satliba se 30 degree ni masigi OP with arrowhead asina the displacement 40 km 30 degree east of north to represent the way. The vector OP with arrowhead represents a displacement of 40 km 30 degree east of north. So classify the following measures as scalars and vectors. Makagi singasi scalars vectors khandu u haibani. Roman number 1 10 kg haibasi scalar ni 2 meters northwest haibasi the vector quantity ni 40 degree. Roman number 3 40 degree haibasi scalar ni 40 watt haibasi scalar ni 10 to the power 19 coulomb haibasi scalar ni 20 meter per second square haibasi acceleration ni masi the vector quantity ni. Classify the following as scalar and vector quantities. Makagi singasisu scalar amasung vector quantity sing group ka makhan khaidu u time period haibani time period habasi scalar ni maikai ga wafam khana di distance habasi su scalar ni force habasi di vector quantity ni velocity habasi di vector quantity ni work done habasi di scalar ni. In figure 10.6 as in this picture is the yegreba city square see the identify the following vectors co initian hai harokpa manaba vectors sing equal vectors sing collinear but not equal parallelly oraga equal oidaba vectors sing khaidu haibani. For Roman number 1 co initian haibadi harokpa manaba vectors sing haibani harokpa manaba vectors sing the a vector siga d vector ga corner starting tarokpa vector ngakani ani si co initian ni equal vectors haibani b vector siga d vector siga side b vector sina side asibu mausile d asin side asibu mausile animak downwards maike chap mane equal vectors collinear but not equal collinear haibadi parallel or but not equal mane mana dabadi a ga siga di mabani di equal di oidare parallel over vectors sung oire asumna. Question number 5. Answer the following as true or false. Makagi singasi chuminataga lali pakumpiu. A vector n minus a vector are collinear. Vector masaga magi negative padi collinear oibra hangmani true chumme masidi. Parallel vectors ni two collinear vectors are always equal in magnitude. Collinear vector ani matam punamakta magnitude managani false ni masidi. Magnitude manadra basuyai. Two vectors having same magnitude are collinear. Magnitude manaba vector ani parallel oigani cd false ni. Ruma number 4 the two collinear vectors having the same magnitude are equal. Parallel over collinear over vector ani magnitude manarabadi equal or high statement as false ni.